what is creep and its failure. Okay, so creep and failure. So creep is a time-dependent permanent deformations of materials subjected to a constant stress over an extended period, typically occurring at a high temperature above 0.4 times the material's melting temperature in an absolute scale, that is in Kelvin. So whatever the melting point of a material, that is, suppose, you know, just take an example of a material that are having a melting point like 600. Okay, so what we can say at a high temperature means 0.4 times. It means what would it be? 600 into 0.4. It is around 240 degrees C. That is known as high temperatures. Okay, just above the zero point 0.4 times the material's melting temperature in absolute scale means we have to calculate in a Kelvin, not in a centigrade or in Fahrenheit, that we just need to calculate in a Kelvin. Okay, so it is a significant concern in applications like the power plants, jet engines, nuclear reactors, and gas turbines, where the material experiences the prolonged exposure to the high temperatures and stresses. So where the creep occurs whenever a material having a load. Due to the load there must be a stress that will induce in the material, but along with the stress they are having a very high temperature. So the stress or the load has been applied at a high temperature over the material, so the stress induced is at a high temperature. Due to that stress is that due to that stress the failure occurs or the deformation occurs, that is known as the creep. Okay, so normal, if it is being that we can say it is crack or it deformed, or we can say the material failed. But for the same load but at a high temperature, the material is exposed to have a high temperature, then they are having a load, and due to that load they must be having a stress, and due to permanent loading there is a permanent stress, and that permanent stress will you know basically induce will create a deformation inside the body. But that is a different from the normal. Like here material is exposed to the high temperature. What kind of the high temperature that they are having is just like a zero point 0.4 times of their melting point. So whatever the material that we are having for this particular purpose, they must be having a temperature more than zero point 0.4 times of their melting point. Suppose they are having the 600 Kelvin, we must have to measure the temperature in a Kelvin scale. Though we are having two different or more different scales as well, but what we have asked to do, that we need to convert whatever the temperature that has been given, we must have to convert into the Kelvin first, and then we can multiply with 0.4%. Okay, I mean you can say that 0 0.4, and that would be like, if just take the example that we are having six a material which are having 600 Kelvin as a melting point, then what would be the high temperature where the stress would be applied and the creep will occur? That would be like zero point 0.4 time of 600, which is going to be having, which is going to have like 240 Kelvin. Okay, and for that we have, I mean this is a temperature set, or you can set the above the temperature, or it's a minimum. Okay, it's a minimum criteria. Below that, if we will keep the temperature, that will not be count as a creep. Okay, so we must have to raise, or we must having the temperature more than 0.4% times of melting point. Okay, melting point is the kind of the temperatures. It's not a point. Point means it's a temperature. Okay, so that at a temperature where the material start melting. Okay, that is known as melting point. Okay, so it is a significant concern in application of power plants, jet engines, nuclear reactors, and gas turbines. Why? There is a prolonged exposure of the high temperature and stresses. What happens here? I mean, whatever the example that we have taken here, for all examples that are having exposure of high temperature, along with that they are bearing, or they are sustaining the stress as well. For that there must be inducing some failure, and that failure is known as creep. Okay,